All right, hey everybody, let's get started. Okay, so we're going to do two sections, 3.1 and 3.2. We'll start with 3.1. Just put that up there. Okay, so this section is about complex numbers, which doesn't really mean anything fancy. Basically, what a complex number is just this letter I, and all it means is the square root of -1, which before we said we weren't allowed to do. Like before, if we had a situation where we had like the square root of -30 or whatever, we would just say that doesn't exist or no solution or something along those lines. But in this section, we'll take care of that, and we'll just, that number that we come up with is called a complex number. So this is just a bunch of those homework examples. So like questions 1 through 10. Like say if we want to find something like the square root of -11. So the way we simplify that, we're always going to be using these one square root properties. Like if we have something like this, the square root of a times b, this is the square root of a, square root of b. So we use this over and over throughout this section. So using this one property over here with this problem, we can rewrite this inside the square root of -11. If we're showing like all the steps, we can say this is square root of -11. So this is going to be square root -1 times 11. And then using this one property up above, we can say that's the square root of -1 times the square root of 11. And then using this guy, the I is equal to square root of -1. This is just equal to I times square root of 11. The main takeaway from all of this is if we like just put all this into one line, if we ever have the square root of a minus and then a number, just immediately we could say this is going to be I and then square root of that number. So you don't really need to think about all these steps going on. So like another example, say if we were going to do the square root of -45. So what we could do here is to say this is going to be I square root of 45. And then we can simplify square root of 45. So the way we can do that is we can rewrite the inside of 45. So this is going to be above I. We can write 45 as 5 times 9. And this is then using this one property above, the property that we keep using. This is going to be I. Then square root of 5, square root of 9. And then we know square root of 9 is 3. So this is going to be 3I square root of 5. Maybe one more quick one. Say if we wanted to do the square root of minus 36. So the first step, we can just take that minus sign in the front. So this is going to be I squared of 36. Then we can rewrite 36. So this is going to be, oh, sorry, let's do 32. Or this might be fine. Yeah, let's keep it like this. So this is going to be I. And then we can rewrite 36 as 9 times 4. And then we can just use that property above. This is going to be I square root of 9 square root of 4. And then this is just going to be equal to I. We know the square root of 9 is 3, so we put a 3 there. And we know the square root of 4 is 2, so we'll put a 2 there. So this is just going to equal 6I. So really nothing new here. All of this is if we see a minus sign, just the first step is we get rid of the minus sign and put an I onto the outside. Okay, how about something like, this next bit. So we said that I was just the square root of -1. So we know that if we square a square root, the square root sign just goes away. So this sort of like leads us to believe that if we square I, well, this is just going to be the square root of -1. We square that guy. Let's just leaving the left-hand side as I squared. Can't really simplify that too much, but if we square the square root of -1, the square root sign just goes away. So this is going to be -1. So if we ever see an I squared, that's just the same thing as -1. Okay, so with that, we can do things like, let's go ahead for a second. So this is going to be like number Kind of jumped ahead a little bit. That doesn't matter. We can do like number 44, and then we can go back to some other ones. So what we can do here is we can just multiply it like FOIL out two numbers. So this is 44. This is so 5 minus 2y and minus 1 plus I. So if we want to multiply two complex numbers together. So for the most part, we can just think of this I as just a variable. Like this isn't too hard. Just pretend like the I is an X over here and just FOIL this out like how we normally FOIL it out. So nothing really new here. You know, we could put the 5 to this minus 1, then we put the 5 to this I, then the 2i to this minus 1, then the 2i to this I. So just like how we'd FOIL out normal numbers. And then we'll worry about this at the very, very end. So if we're doing this, so the 5 times the minus 1 is minus 5. The 5 times the I is just 5i. The minus 2i times the minus 1 is positive 2i. And then the minus 2i times the I is going to be minus 2i squared. So if that I was just an X, that nothing would change here. This is the same thing you'd always get. So you're just FOILing out like how we always FOIL out. So this is going to be minus 5. And if we combine like terms, the 5i plus the 2i is 7i. And then minus 2i squared. So now what we can do is if we see an I squared, we can put a minus 1 in. So this is just going to be minus 5 plus 7i minus 2 times minus 1. So it's going to be minus 5, 7i plus 2. So minus 3 plus 7i. So that's an example of multiplying the numbers together. And during this example, we also added them. So, you know, just like how we can always add, you know, it's like 5x plus 3x, that's equal to 8x. We did that same thing right here. We had 5i plus 2i, so that's going to be 7i. So we can still, you know, combine like terms. So for the most part, we're just treating this I as just a variable. And the only thing that happens at the end, if we see an I squared, we put a minus 1. You know, maybe like an example like number 12, where we're adding two numbers together. We have minus 6 minus 5i, and we are going to subtract, add 9 plus 2i. So we're adding these numbers, so we can just kind of forget about these parentheses. So we have minus 6 minus 5i plus 9 plus 2i. So combine the like terms, we have a minus 6 and a 9, so that's going to be a 3. And then a minus 5i and a 2i, so a minus 3i. Do an example like 21, so like a subtraction one. We have 10 plus 7i minus 5 plus 3i. So here we need to distribute that minus sign. So 10, 7i, minus 5, minus 3i. So just distributing the minus sign through the second set of parentheses. So then we have a 10 and a minus 5, which is just a positive 5. And then we have a 7i minus a 3i, so a 4i. So again, basically all we're doing is treating this I as a variable right now. So nothing really special is happening. Let's do about like 19. So this one wants us to do 3 plus square root of minus 16 plus 2 plus square root of minus 25. So in this problem, what we can do, let's just first get rid of these parentheses. So we have 3 plus square root of minus 16 plus 2 plus square root of minus 25. Then we could say, well, this is going to be 3 plus, and getting rid of that minus sign, we have I square root of 16 and plus 2. And again here, I square root of 25. So we have 3 plus, and we know the square root of 16 is 4. So we have 4i plus 2. And we know the square root of 25 is 5. So 5i. And then combine the like terms, we have a 3 and a 2. So that gives us 5. And then a 4 and a 5. So that gives us 9. So 9i. We could do 31. So 31 says what we want to do is square root of minus 4 multiplied by the square root of minus 36. So what we have here is, well, like we said before, whenever you have a minus sign in the square root, we just get rid of it and put an I on the outside. So we have I square root of 4 times I square root of 36. Well, then we see we have two i's, so I times I is I squared. Then we have square root of 4, which is 2, square root of 36, which is 6. We know I squared is minus 1, so remember I squared is equal to minus 1. So this I squared turns into a minus 1. Then we have 2 times 6, which is 12. So minus 1 times 12 is just minus 12. Okay, about 35. So in this problem, we have 7i multiplied by 2 minus 5i. So just like before, we can just distribute. The 7i goes to the 2, the 7i goes to the 5i. So 7 times 2 is 14, so we'll have a 14i. So basically it's pretending this I is a variable. And then 7i times 5i, that's going to, minus. So we'll have minus 35i squared. And this is going to be, so 14i. And then like we said before, I squared is minus 1, so put a minus 1 here. And so then we'll have 14i. Then we have this minus 35, so plus 35. So again, the entire time we're doing these problems, just always think of I as a variable. And if that's the way you're thinking, then everything in this section is basically what we've been doing this entire course so far. Just combining like terms and stuff. The only time things change is if we have an I squared and we just turn that into a minus 1. But that doesn't happen until the end of the problem. So you see here, like if this was just 7x, 2 minus 5x, before quickly, we would just distribute and we just see, okay, that's 14x minus 35x. Minus 35x squared, because you have x times x. So this little bit is basically just going from this line to this line, but we're replacing the i's with an x's, but nothing changes. It's still the same thought process as what we just did over here. So you see we have 14i minus 35i squared, but here we have 14x minus 35x squared. So for the most part, we just treat this I as a variable. And then whenever we see an I squared, we just turn it into a minus 1. So we do 47. It's a different looking one. So 47 says we have 3 plus minus 16, or sorry, 3 plus the square root of minus 16. And then 2 plus the square root of minus 25. So what we can do first, let's just simplify inside the parentheses. So we'll have 3, and then so minus 16. We can put an I on the outside, and then the square root of 16. Then an I on the outside and the square root of 25. So just getting rid of the minus on the inside. So now let's see if we can simplify a little bit more. We have 2 plus square root of 16 is 4, so we'll have 4i. And 2, oh, sorry, that needs to be a 3. Just wrote that one wrong. And then we have 2 plus, so the square root of 25 is 5, so 5i. So now we can FOIL. So we have 3 times 2 is 6. 3 times 5i is 15i. So just going this to here, that to here, this to here, and then that to here. So the 3 times the 5i is 15i. Then 4i plus 2 is 8i. And then 4i plus 5i is 20i squared. Okay, so we can combine. Oh, I think I made it. Did I make a typo? No. No, we're all good here. So we just have a 6. Then we have a 15i plus an 8i, which is a 23i. And then we have a 20i squared, so 20 times minus 1, because we're turning the I squared back into a minus 1. And so what we have here is, so basically 6 times minus 20, or sorry, 6 plus minus 20, which is minus 14. So we have minus 14, and then just plus the 23i that we had up there. Okay, so we'll go with that one. Let's see what else we've got in here. All right, so far all we've done is multiplication, addition, and subtraction, but we can still, now the next thing we're going to do is division. So let's talk about that. Like, say if we want to divide, we'll just do it by an example. So we can do the numbers. Let's do 66. So we want to solve this. We want to simplify I into 2 plus I. So I guess like the directions, if we put it onto a test, let's write it like that. What we want to say is we want to put I divided by 2 plus I into A plus B I form. Now this A plus BI form, that's basically how this answer looks. So A plus BI form just means we have a number plus another number times I. So just like how we have right here, we have a number plus another number times I. So that's A plus BI form. So we wanted to make it look like that. Right now, this piece right here, this does not look like A plus BI form. So we need to have just a number and then plus, another number with an I attached to it. So the way we do that is, so let's take our number over here, the I, 2 plus I. So the way we do it here is we look at the denominator. So the denominator is always going to be given an A plus BI form. So if you look at the denominator, here's, A plus BI. So what we're going to do is we take our denominator, but we're going to change that sign. So if it's a plus sign, we turn it into a minus sign. And what we're going to do is do 2 minus I, 2 minus I. And multiply the top and the bottom by that number. So really all we're doing is multiplying by 1. This number here is just 1 written in a different way. 2 minus I divided by 2 minus I, that's just equal to 1. So whenever you have, A divided by A, whenever the top is the same thing as the bottom, that's just equal to 1. So that's sort of the technique when we're doing these problems. So if this was a minus sign over here, we would make this a plus sign, which we can do that in the next example. So you always do the opposite sign and you always just look at the bottom. So now what we're going to do is simplify this. So, we're just multiplying fractions. So we multiply the tops and we multiply the bottoms. So this is going to be I, 2 minus I. And on the bottom, we'll have 2 plus I, 2 minus I. Okay, so now this is going to equal. So on the top, what we're going to have is distributing that I, will have 2 times I. And then I times minus I, so minus I squared. And then on the bottom, so notice here, this is like, a nice thing to have memorized. If you have A minus B, A plus B, this is equal to A squared minus B squared. And that's what we have right here. We have, 2 plus I, 2 minus I. So the same thing as this setup right here. So just to save time from factoring, what we can say is, well, this is just going to be the first thing squared, which is 2. So this is going to be 2 squared. And then minus the second thing squared. Our second thing is I, so I squared. So what we have here then is the top is going to be 2I minus, remember here we have an I squared, so I squared is minus 1. And on the bottom we have 2 squared is 4 minus, and again we have an I squared, so minus 1. So on the top we have 2I minus a minus 1, so 2I plus 1. And on the bottom we have 4 minus a minus 1, so 5. So then if we simplify this, so we can break up this fraction. So we can say this is the same thing as 2I over 5 plus 1 over 5. So we're just breaking we're breaking this fraction into 2 separate fractions. And then we can't simplify anymore. So this is going to be our final answer. So notice this is an A plus BI form. So this is, let's write this backwards. So this is actually equal to 1/5 plus 2I divided by 5. So just writing it in the reverse order. So this piece right here This is in our A plus BI form. And so the way we put it in the A plus BI form is just we start, and this is always going to work. Oh, sorry, this is oh no, we're all good here. By doing this step right here, where we take the bottom, change the sign, and multiply the top and the bottom by it. So let's do several more of those ones. So how about like 70? So 70 says 5 minus I, and then minus 7 plus 2I. We did a, no, let's do a minus 1. So let's do 68. Let's change this. No, I don't want to do 68. I want to do a little bit of a harder one. 69, we'll do that one. Okay, so 69 says we have 4 plus I. And on the bottom, we have minus 3 minus 2I. So you see now on the bottom, what we have is this minus sign here. So what we're going to want to do is turn that into a plus sign. So we're going to do minus 3 plus 2I. Oh, sorry. How do we want to say this? Let's put this into A plus BI form again. So we start with our number. Now we're going to multiply the top and the bottom, but just change this thing into a plus sign. Sorry. Minus 3 plus 2I. Minus 3 plus 2I. Okay, so now on the top, we have to FOIL. So we're going to have 4 times minus 3 is minus 12. 4 times 2I is 8I. I times minus 3 is minus 3I. I times 2I is 2I squared. And on the bottom, so again, we have that same thing. Here's our A minus B, A plus B. So we basically just do A squared minus B squared. So A is minus 3, so we're going to have minus 3 squared. Minus, and then B squared, so which is 2I squared. Again, all we're doing is basically just that shortcut, this thing right here. We could get the same answer just by FOILing out, like doing minus 3 times minus 3, minus 3 times 2I, minus 2I times minus 3, minus 2I times 2I. But it's good just to use those shortcut equations. So if we have a situation like A minus B, A plus B, we'll just do A squared minus B squared. So this is like our A. This is our B. So we're doing A squared minus B squared. And that's because we're written in the form, here's A minus B, and here's A plus B. So whenever we have that form, we can just do A squared minus B squared. All right, so let's keep going. We simplify the top a little bit. So there's a minus 12. We can't combine that with anything just yet. Then we have an 8I minus a 3I, so that's a 5I. And then a 2I squared, so that's going to be 2 times minus 1. On the bottom, we have minus 3 squared, so 9. And minus 2I squared. So 2 squared is 4. And then I squared is minus 1. So we have that. So now on the top, we have, so here's a minus 12 plus a 2 times minus 1. So that's a minus 12 minus a 2, which is a minus 14, plus 5I. On the bottom, we have 9 minus minus 4. So 9 plus 4, which is 13. So breaking this up into 2 fractions, we have minus 14 over 13 plus 5I over 13. All right, and so this is going to be our answer in A plus BI form. Okay. How about, I guess, I don't know, 78? It seems fine to do. So 78 says we have 3 plus 2i all over 1 minus I. We're going to add that to 6 plus 2i all over 1 minus I. So the first thing we can do here is, well, we have the same denominator. Let's just add the tops together. So this is going to be 3 plus 2i plus 6 plus 2i, all divided by 1 minus I. So we're just combining those two fractions together, which is okay because we have the same denominator. The denominator is 1 minus I and then 1 minus I. So those are the same things. Now let's see, what do we have on the top that can combine together? 3 and a 6, that makes a 9. And then a 2 and a 2, so we have, to copy this right? 2i, 2i. Yeah, so 2i and 2i, so we have 4i. And the bottom is still 1 minus I. So now what we're going to do is we're going to take this piece. We want to simplify that. We want to turn that into a plus bi form. So let's just rewrite that. We have 9 plus 4i, 1 minus I. And so now what we're going to do is do 1 plus I, 1 plus I. Again, we're doing the 1 plus I because we do whatever's on the bottom, but we change the sign. The sign's a minus sign, so we're turning it into a plus sign. Okay, and so on the top now, we're going to have 9 times 1, which is 9. 9 times I, which is 9i. So we're just foiling now. 9 goes to the 1, 9 goes to the I, 4i to the 1, and then 4i to the I. So now 4i times 1 is 4i. 4i times I is 4i squared. Now on the bottom, again, the a, here's a minus b, here's a plus b. So we're going to do a squared, which is 1 squared. And then minus b squared, which is I. So minus I squared. Okay, so what does this equal? On the top, we have 9. 9i plus 4i is 13i. And then 4i squared, so 4 times minus 1. On the bottom, we have 1 minus I squared, so 1 minus minus 1. So on the top, we have a 9 minus a 4, so that's a 5, plus 13i. And then divided by 2. So this is going to be 5 halves. Plus 13 over 2i. Okay. Okay, in our last problem, so just to again reiterate, so we have this I squared is equal to minus 1. So we want to use this to simplify something along the lines of, so we'll say if we want to simplify I to the 21. So one way we can do this is well, how can we rewrite 20? So there's sort of a pattern to do this one. Let's do 2 examples. So I to the 21 and I to the 42. So the difference between these 2 problems is only going to be that this number right here, 21, is an odd number. So 21 is odd. And then 42 is an even number. So if we're doing the odd situation, so this is how an odd one always goes. So we have I to the 21. What we can actually do is just rewrite this as I to the 20 plus 1. So you're always going to do it like this. So whatever your odd number is, just write it as 1 less than that plus 1. And then we'll using properties of exponents. Where can we squeeze this in? We know that x to the a plus b, this is just equal to x to the a, x to the b. This is just an exponent rule to have memorized. So if we ever have adding exponents, we can break that up like this. So here we have I to the 20 plus 1. So this is just going to be equal to I to the 20, I to the 1. But I to the 1 doesn't mean anything. That's just going to be I. So we have I to the 20 times I. So now what this does is we just broke this problem into I to the 20 times I. So now we're going to there's another exponent rule we want to use, that if we have x to the a to the b, this is going to be x to the a times b. So we know we can write 20 as 2 times 10. So this is going to be I to the 2 to the 10th power times I, because 10 times 2 is 20. But then now we know I squared is minus 1. So this is going to be minus 1 to the 10 times I. And we know that if we ever have a minus to an even number, that's just positive 1. So this is going to be positive 1 times I. And that's going to equal I. So what we just did is we used this property up here to figure out what I to the 21st power is. And this is going to always be the technique for an odd number if we have an odd number power. So we always take our power 21, which is an odd number, and we rewrite that as 20 plus 1. Then we use this first exponential property, and since we have a 20 plus a 1, we can just write it like this. So that's using this top property. And then just I to the 1 just means I. And then our next thing we want to do is, well, we have I. So we're going to use their second property that if we have x to the a to the b, that's x times a, x to the a times b. So we can rewrite 20 as 2 multiplied by 10. All right, and so we know that I squared, well, that's minus 1, so we replace that with minus 1. And then minus 1 to the 10th power is just positive 1, and then we have positive 1 times I, which is I. So now this next one, which is our even situation, we want to simplify I to the 42. So notice I to the 42, 42 is already an even number, so we can kind of skip to this step. The whole point of this step is, well, an even number can always be written as 2 multiplied by something. So what we know here, that we can just rewrite this. I to the 42, well, that's going to be I to the 2. We know 42 is going to be 2 times 21, so that's going to be 21 power. Again, I squared is minus 1 to the 21st power. And an odd number, sorry, a negative to an odd number is still going to be negative. So this is just going to equal minus 1. So both of these problems, this is the only two types of problems we can have. We either have an I to an odd number or an I to an even number. But regardless, it's the, if we have an I to an odd number, it'll always be this number of steps, and it'll always be exactly these steps. And if we have I to an even number, it's always going to be these steps, and it'll always be exactly the same number of steps. Okay, I think that's actually everything from this section. Yes, let's move on to section 3.2. All right, what do we have in this section? So this section, so before, say if we wanted to solve an equation like x squared plus 1 is equal to 0. You know, maybe we could subtract the 1 over. So we have x squared is equal to minus 1. And then we could take the square root of both sides. So we get x is equal to plus minus square root of minus 1. But before today, we would just say this is no solution because we can't have the square root of a negative number. But now that we know that I is equal to the square root of minus 1, what we could say is, well, this is just going to be x is equal to plus minus I. So now we do have a solution to something, an equation like this. So now we have, basically, whenever we have x squared, you know, plus some things is equal to whatever, we can always solve for it now. Before, if we had a minus inside of the square root, we'd just say no solution. But now if we have a minus in the square root, we just call that I. So in this situation, we're going to have x is going to be equal to plus minus I. So let's do, so the first several problems in the book, like 1 through 10, these are just normal problems that we've been doing that don't have i's. So for example, let's say if we wanted to do problem number 4. So which says x squared plus 6x plus 8 is equal to 0. I guess actually now, before we talk about this, there's one other thing that we want to do from this section. Does this section have completing the square? I don't think so. Oh, it does. Well, We'll talk about that in a second. So the main idea from this section now is that, well, first we're going to talk about the quadratic formula. See, quadratic. And we use the quadratic formula to solve ax squared plus bx plus c is equal to 0. And so before, when we had something like this, we had to factor, which we should always be factoring if we can. But if we can't factor, now we know a way to solve this by just using an equation. We know that x is going to be equal to, so negative b, then plus minus the square root, b squared minus 4 times a times c, all over 2 times a. So let's use this with an example. So say if we have something like this, x squared plus 3x plus 2 is equal to 0, and we want to solve this. So when we were solving this in previous sections, we wanted to factor first, and we still always want to factor first. The only time we're going to use the quadratic formula is if factoring is not possible. But for this problem, let's do it both. We'll solve this one by factoring. We'll solve this one by the quadratic formula. So let's start by factoring. So we know we can factor this one. This one just factors kind of quickly into x plus 2 and then x plus 1. We know that because 2 times 1 is 2 and 2 plus 1 is 3. So we set this equal to 0. So we have here is x plus 2 is 0, x plus 1 is 0, and this one just gives us x is equal to minus 2, and this one gives us x is equal to minus 1. So this is just by the factoring method, which is always should be your first method, always should be the go-to method because it's the quickest. So now what we can do though is the quadratic formula. So let's solve that same problem again. X squared plus 3x plus 2 is equal to 0. Let's solve this using the quadratic formula. So just so we have it on the screen, again, the quadratic formula says x is going to be equal to negative b plus minus the square root b squared minus 4ac all over 2 times a. So, and then what these a, b's, and c means, it means that we have ax squared plus bx plus c is equal to 0. So if we look at our problem above, we want to know, okay, what is our a, what is our b, and what is our c? So in this problem, a is the number in front of x squared. If we look right there, there's just a 1 there. So in this situation, a is equal to 1. B is in front of x, well, that's a 3. C is just the number at the end, which is a 2. So now to solve this equation, all we got to do is just plug everything into the quadratic formula. So what we get is x is equal to negative b, so negative 3, plus minus the square root of b squared, so 3 squared, minus 4 times a is 1, c is 2, and then all over 2 times a, so 2 times 1. So let's simplify this. We have minus 3 plus minus the square root, so 3 squared is 9. Then we have minus 4 times 1 times 2, which is just 8. All divided by 2 times 1, which is just 2. So we have minus 3 plus minus. So 9 minus 8 is 1. So we just have the square root of 1, which is just 1, all divided by 2. And what this plus minus sign means is we have this. We have two answers. So we have x is going to be equal to 3 plus 1 over 2. And then we're also going to have x is going to be equal to 3 and minus 1 over 2. So 3 plus 1 over 2, that's going to be 4 over 2, which is 2. 3 minus 1 over 2, which is going to be 2 over 2, which is 1. So we have these two answers, 2 and 1, which is exactly what we got up here. Oh, sorry, did we make a mistake? Minus 3. So we dropped that. That's minus 3 plus 1, minus 3 minus 1. So this needs to be a minus and a minus. So we get the answers of minus 2 and minus 1, which is exactly what we got up here when we just did the factoring method. But notice that when we can factor, we did this problem just in a couple of steps. But when we're doing the quadratic formula, it takes multiple steps to get the answer, just because it's a little bit more tedious. However, now let's do an example where we actually need to use the quadratic formula. So say if we had something like this, we want to solve x squared plus 3x plus 4 is equal to 0. So again, we always look at, can we factor this? And so how do we know that so say if we want to factor this, well, we know there's a 1 in front of the x squared. So this first step for factoring is doing this. And now what we want to do is, can we find numbers that these two numbers are going to multiply up to 4 and then add up to 3? But there are no numbers that multiply up to 4 and add up to 3. So we're not going to be able to factor this problem. Just for the reason we just said, we can't find numbers that multiply up to 4 and at the same time add up to 3. So in this problem, factoring is not possible. Okay. But now that's not a problem because we can just do the quadratic formula. So again, the quadratic formula, we know that x is just going to equal to negative b plus minus square root b squared minus 4ac all over 2 times a. And we have ax squared plus bx plus c is equal to 0. So in our problem, again, our a is 1, the number in front of x squared. Our b is 3, the number in front of x. In this problem, our c is 4, just the number at the very end. So let's just plug all those into the quadratic formula. So x is equal to negative b, which is negative 3, plus minus the square root of b squared, so 3 squared, minus 4 times a is 1, c is 4, all over 2 times a, so 2 times 1. So what does this equal? We have minus 3 plus minus 3 squared is 9, minus, and then we have 4 times 1 times 4, which is 16, all divided by 2 times 1, which is just 2. Now minus 3 plus minus. So we have 9 minus 16, which is minus 7. So now we have minus 7 in there. Okay, so now what we can say is that, oh, so again, we have that, let's get rid of that plus minus sign now. So we have two answers. We have x is going to be minus 3 plus the square root of minus 7 over 2. And then we have x is going to be equal to minus 3 minus the square root of minus 7 over 2. But now we can simplify these a little bit more. We have minus 3. So we have a minus in the inside of a square root. Let's just write that as I square root of 7 divided by 2. And then over here, we have minus 3 minus I square root of 7 over 2. So we have these two answers. So again, this is an example now where we have to use the quadratic formula because we can't factor. And even though we get a minus sign instead of our square root at the very end, like we get a minus sign right here, like before, as that would be a no solution. Now we know how to take care of that. All we do is get rid of that minus sign on the inside and write an I on the outside. See right here, we have square root of minus 7, but instead we're going to write I times the square root of 7. Okay. Let's do number 11. So number 11 just tells us we have, so 5x squared plus 10 equal to 0. So what we could do here is we could subtract the 10 over. So we get 5x squared is just equal to minus 10. Then we can divide the 5 over. X squared is equal to minus 2. Then we take the square root of both sides. X is going to equal plus minus square root of minus 2. And then our final step here, just instead of having a minus 2, we'll put that as an I times square root of 2. So plus minus I square root of 2. So what this means is we have two answers. We have x is equal to I square root of 2, and x is equal to minus I square root of 2. So this plus minus sign just means we have two things. We have the positive version and then the minus version. Okay, what else do we got? Okay, so the next way, so we talked about the quadratic formula. We stop right here. So let me look at the problems we needed to do. And then, okay. So we talked about the quadratic formula. Did some examples with those. No, the next way, the next thing we can do is something called completing the square. So this is another way to solve like ax squared plus bx plus c is equal to 0. So this is going to be called completing the square. Sorry. So this way is a little bit more complicated. You should never use this method to solve, but it's just in the book, so let's just talk about it. So the way we do here is maybe it's just best by learning by doing a couple examples. Let's start with number 29. So 29 says is we have x squared plus 6x minus 7 is equal to 0. With this one in particular, we could actually solve this by factoring quite easily. We could factor this, but let's do this one solving by completing the square. Again, you should only do this if the directions tell you to solve by completing the square. It has a reason. It helps when we're doing like equations of circles, which doesn't really matter too much in this problem. But other than that, solving this equation by completing the square is kind of like a waste of time. But it's in the book, so let's just talk about it. So the methods for completing the square. The first thing we do is, so it's all we have. It's always something like this: ax squared plus bx plus c is equal to 0. Completing the square is always for these type of problems, and that's what this one is over here. So the first thing we're going to do is we're going to take this term that doesn't have an x attached to it, and we're just going to move it to the other side. So it's the minus 7, move it to the other side. So we're going to have x squared plus 6x is equal to positive 7. So now we're going to do this step where we take the number attached to the x, which is a 6. We're going to divide it by 2. We're going to square it. So we always take that number, the 6, the number attached to the x. We take it, we divide by 2, we square it. So that's going to be 3 squared, which is 9. And then what we're going to do is we're going to add this number to both sides of the equation. So we're going to write this as x squared plus 6x plus 9 is equal to 7 plus 9. The reason why we just did that is now we can factor this left-hand side. So this the left-hand side, remember, so here we have a 1 in front of the x. So if we are going to factor it, it's going to look like this. So we need, what are the numbers that multiply up to 9 and then add up to the middle number, which is 6? Well, that's just going to be 3 and 3. We know 3 times 3 is 9, and 3 plus 3 is 6. So we factor the left-hand side into x plus 3 times x plus 3, and then the right-hand side is 7 plus 9, which is 16. So the left-hand side, what we can write this as is x plus 3 squared, because we have x plus 3 times x plus 3, and that's going to be equal to 16. But now what we can do is, well, we have something squared is equal to 16, so we get to take the square root of both sides. So this is telling us that x plus 3, just taking the square root of the left-hand side, because then the square is going to go away. Well, this is going to be plus minus square root of 16. So what we have is x is going to be equal to minus 3 plus minus the square root of 16. So x is going to be equal to minus 3 plus minus the square root of 16 is 4. So what we have is x is equal to 3 plus 4, which is 7. And we have x is equal to, oh, sorry, why do I keep forgetting the minus sign? We have, it's minus 3, so minus 3. So we have x is equal to minus 3 plus 4, which is 1. And x is equal to minus 3 minus 4, which is minus 7. All right, so the next one, let's do several more like that. How about 31? So again, let's just solve by completing the square. So we want to get all the x's on the same side and just that number on the other side. Like that's kind of like the first step we did up above. We got our x's on one side and then just the number on the other side. So here, let's move that 8x over to the left-hand side. So this is going to be x squared minus 8x is equal to minus 9. So now what we do is we always take that number that's in front of our x. In this situation, it's a minus 8. So we take our minus 8. We're going to divide it by 2, and we're going to square it. So 8 divided by 2, that's going to be 4. Well, minus 4, but it doesn't really matter because we're squaring it. So minus 4 squared is positive 16. So what we're going to do is now we're going to take that number and add it to both sides. So we have x squared minus 8x plus 16 is equal to minus 9 plus 16. And now we can factor the left-hand side. So again, we'll have an x plus something, x plus something is going to be equal to minus 9 plus 16, which is 7. So what are the numbers that we see complete the factoring step? What are the numbers that multiply up to 16 but add to minus 8? And that's going to be minus 4 and minus 4. So we know minus 4 times minus 4 is positive 16, but minus 4 plus minus 4 is going to be minus 8. So what we have actually is x minus 4 is equal to 7, which is like saying x minus 4 squared is equal to 7. And now, just like before, we can take the square root of both sides. So what we have here is x minus 4 is equal to plus minus square root of 7. And then we would add the 4 over. So we get x is equal to 4 plus minus square root of 7. Okay. Well, what are the ones that you have to do? Okay, that's good. So that takes care of the questions you have to try on your own. So for the next bit, like the next homework questions is like 47 and 51, but we already kind of did those. Those are just doing quadratic formula ones. So the last bit, what is this? 79 and 81. Okay, yeah, so let's talk about these last two problems. So for these problems, let's just do these ones together. So let's do 80. So what this one is asking us to do is x to the 4th plus 3 is equal to 4x squared. So whenever we have these ones, and usually we just have an x squared and an x, but now we have an x to the 4th and an x squared. Let's just move everything on one side and set it equal to 0. So what we're going to do is subtract that 4x squared over. So we'll have x to the 4th minus 4x squared plus 3 is equal to 0. So how we do these problems is, so notice that we have an x to the 4th and we have an x squared. Just to make this look a little bit nicer, let's make this new variable u, and we'll call u to be x squared. And so if we were to square both sides, this tells us that u squared, that's going to be x squared squared, if we just square both sides, which is x to the 4th. So actually, we can rewrite this problem. So x to the 4th is u squared, so we have u squared minus 4. We said x squared was u, so just u, and then plus 3 is equal to 0. So now this problem looks a little bit more familiar. It just looks like ax squared plus bx plus c is equal to 0. So to solve this one, we can actually just solve it by factoring. So we can, we have u. So we can factor this piece. So what are the numbers that multiply up to 3 but add up to minus 4? And that's going to be minus 1 and minus 3. So minus 1 times minus 3 is positive 3. Minus 1 minus a 3 is minus 4. So this is equal to 0. So again, this should be familiar. We know how to solve this. This is going to be u minus 1 is equal to 0. U minus 3 is equal to 0. And here we get u is equal to 1 and u is equal to 3. However, the problem wants us to solve for x. It doesn't want us to solve for u. But we know that u is equal to x squared. So if we say u is equal to 1, well, that just means x squared is equal to 1. If we say u is equal to 3, that just means x squared is equal to 3. So now to solve both of these for x, we can take the square root of both sides. So here we're going to get x is equal to plus minus square root of 1. And here we're going to get x is equal to plus minus square root of 3. And so we have these, well, square root of 1 is just 1. So we have x is equal to the plus minus 1. So there's two answers here, and then we have x is equal also to the plus minus square root of 3. This was not 880. Okay, and then another one we could do 83. So 83 has us saying y to the 4th power plus 4y squared minus 5 is equal to 0. So again, we have that same problem where you have like a y to the 4th and a y squared, which kind of maybe just looks visually unpleasing to solve. So let's do that same thing like with that u trick. So let's let u equal y squared. So that tells us that if we did u squared, like we squared both sides, we would get u squared is going to be y to the 4th power. So let's just replace everything. Here's a y to the 4th power. Well, we know that y to the 4th power is u squared. So this is going to be u squared plus 4. We know y squared is u, and then minus 5 is equal to 0. So now we're just in, the ax plus bi plus c is equal to 0 form. So we could try to factor this, but we need to find numbers that multiply up to minus 5 and then add up to positive 4. So we can find those. So that's going to be u plus 5, u minus 1. So 5 times minus 1, that's minus 5. And then 5 plus minus 1 is 4. So this piece factors into this. So what we get is u plus 5 is equal to 0. U minus 1 is equal to 0. Here we get u is equal to minus 5. And here we get u is equal to 1. But just like before, we weren't trying to find u, we're trying to find y. So now we know that u is the same thing as y squared from this box. So u is y squared. So we could do, instead of saying u is equal to minus 5, well, we can say y squared is equal to minus 5. And here we have u is equal to 1. So that just means y squared is equal to 1. And if we take the square root of both sides, we're going to get y is equal to plus minus square root of minus 5. And here we're going to get y is equal to plus minus square root of 1. So what this means is plus minus, instead of saying square root of minus 5, that's just I square root of 5. And this one we just have y is equal to plus minus 1. Okay, that takes care of all the homework problems from this section. So I think this is a good place to end it. So yeah, we'll just pick up tomorrow with section 3.3 and 3.4. If any questions, just feel free to email me. Yeah, otherwise I'll see you guys tomorrow morning. Cool, thank you.